I'm going to just give a quick talk about a project I did, which was actually done in Rust, but in service of programs that I write in Scheme. So I don't know if you guys have heard of Passkeys. They're all the rage now for replacing passwords. I have a YubiKey, which is one of these little things you stick into a USB port to authenticate yourself to a website. So there's a protocol. You can use that. You can use fingerprint readers, iris readers. There's a whole slew of devices like that that you can use in lieu, or in supplement to passwords or instead of passwords. And there's now a web standard called webauthn, W-E-A-U-T-H-N, that implements that. It's unfortunately fairly complicated, like lots of cryptographic-based protocols, but I found a very well-written, well-regarded library written in Rust called webauthn-rs that implements it. Unfortunately, if I want to expand my Scheme web server to support passkeys for my personal apps, I didn't want to have to switch to writing Rust, as wonderful as Rust is. So what I did was I wrote, let's see, so this is why you would want to do webauthn. What I did was I wrote, okay, let me give you a little background. There are two ceremonies in webauthn. One is registering for an account. So this is when you first put in the device and you have some other way of saying, okay, I am who I am, I can prove it, or this is a new account, please from now on trust this device to represent me. So that's the ceremony of registration. And then the ceremony that you execute most often is authentication. So when you come to a new browser and you want to prove that you are who you say you are, you plug your device in or you press your fingerprint on it and so on, and the authentication ceremony runs. And webauthn either says you are authenticated or you are not. So unfortunately, like I said, there were no Scheme webauthn libraries, and it's a big project to write one. So instead of doing that, I wrapped webauthn-rs. It was my first Rust project, but I'm grateful to the team that runs this. Two people in particular on that team were very helpful to me. I submitted my project, and then they told me, oh, you're doing everything wrong with respect to Rust. Here's how you do it right. But they really led me through it like I was their intern. And the result was something that they actually are now including in webauthn-rs as a standard component. My daughter helped me with the AI prompts for this. So this is the proxy that I wrote, talking to the lock on your behalf and then listening to the responses that the lock gives. So the idea is your web server, when it needs to talk webauthn, calls my webauthn-rp-proxy by giving it some JSON. That JSON is then passed to webauthn-rs, which does its magic cryptography, gives you back two components, both as JSON, the part that's supposed to go to the browser and the part that the server is never supposed to share with anyone but can be stored in a database. And then my proxy gives those back to the web server, and the web server can then deliver the part that's supposed to go to the client, and that completes the ceremony. And so, it's basically this kind of thing underneath, right? You have credentials, you have a particular machine, you have an identity and a username, you have a particular unique user ID, but unlike this, the JSON typically tends to be fairly long. So for both ceremonies, I pass some JSON to the proxy passes it to webauthn-rs, gives it back, and that maybe happens 2 round trips, and then you're done. And the great thing is, I did this for Scheme. All I had to do was write a little bit of JavaScript, and now and some Scheme code that knows how to read and write JSON, which there are plenty of libraries for that. And I now have a website that my calendar program, my to-do list, and stuff like that. Those are all authenticated with my little YubiKey now. But the nice consequence of this approach, since it's something that doesn't require super high performance, I can just do it through JSON and a sub-process. What I've built now can be used by any other language. So if you want to do this from Common Lisp or from Python, I'm sure Python has its own libraries, Clojure, or anything else, you can do it. So I encourage you all to look into webauthn-rs and inside it, webauthn-rp-proxy, because now it's part of that. Yeah, and I think my alarm went off and no one called me on it. So, okay. Anyway, does anyone have questions on this?
So where's an example of how we use this from Scheme?
So in 5 minutes, I don't have time to do that.
Okay. I'm just looking for a link.
Yeah.
What do I Google?
So the code that is published is just the proxy code.
Okay.
I haven't yet published. Basically, I have an awful lot of sort of code for my web server that's all tangled up together, and I haven't factored this stuff out. But I documented, I think, pretty well. And if you just look for webauthn-rs, it's on GitHub. You'll find it right away. And then one of the top level projects is one of the top level folders underneath that is webauthn-rp-proxy. And you know, it's pretty straightforward to go from there. You know, especially if you have Claude, maybe. You know, I did this before Claude and so on. But yeah.
Anything surprising or noteworthy about this sort of like scheme on top of Rust combo? Like, would you do it again? You know, or any just observations?
Yeah. So you know, one of my observations is that Rust and Go, they're neither languages that I would like to program in all the time, but they're respectable languages. But the quality of the libraries that are provided by, that are published in those languages is very high. I've been really, really impressed. It's very different than Python, where it's just very haphazard and the APIs are terrible. But Rust and Go libraries just seem to be written by people who have good taste and experience. And this is one of those examples. This webauthn-rs package was just really great. The other one I considered actually was written in Go. So yeah, that was a surprise. There's a little bit of kind of clunky stuff that happens in the JavaScript side of the protocol that's unexplained that I don't really get, but I was able to make it work. Yeah. All right.